Hello guys, welcome to this video. Now in this video we want to determine the nature of flow of blood in the aorta. Okay, so now to determine the nature of flow of a fluid, we have to use the Reynolds number. So the Reynolds number actually determines whether the fluid flow is turbulent or laminar. Okay, so turbulent flow simply means the type of flow which is not smooth, right, so to say. So we know in the aorta, since blood is pumped from the heart, so the flow is actually not constant. Okay, it's not smooth, it is pumped in pauses. Okay, so now to know the type of flow, we consider the value of the Reynolds number. Okay, for example, generally if the Reynolds number is greater than 2000, then we expect the flow to be turbulent, meaning the flow will not be continuous or smooth. But if the Reynolds number is actually less than 2000, then we expect the flow of that liquid to be laminar or smooth. Okay, so we have an example of a question here. Okay, the aorta with that diameter, and we have the flow speed, which is 55 centimeters per second. We want to know if the flow of blood is turbulent in the aorta or not. Okay, so we are given the other parameters like the density and also the viscosity of the blood. Okay, so now what we have to do is simply go ahead and find the Reynolds number for this particular case. Okay, so we're saying that if the Reynolds number is greater than 2000, then the flow is actually turbulent. Okay, but if the Reynolds number is less than 2000, then the flow is actually laminar flow or smooth flow. Okay, so now how would we find the Reynolds number? Well, the Reynolds number is given as Reynolds number equals, we have the speed, which is the flow speed, multiplied by the density of that liquid, multiplied by the diameter of the tube or the pipe, and divided by the coefficient of viscosity. All right, so this is a very simple thing to do. As you can see, it's just a formula here. We have the speed, which is 55 centimeters per second. We also have the density, which is 1050 kgs per cubic meter. The diameter is given there as 2 centimeters, and we also have the coefficient of viscosity. So what we're going to do here is simply first convert, for example, the speed here is given in centimeters per second. We can take that to meters per second first. Also, the diameter is given in centimeters, so we can take that to meters. Okay, so let's go ahead and do that. We can write our data there. So we have the speed. Okay, the speed being equal to 0.55 meters per second. What else do we have? We have the density as 1050 kgs per cubic meters. We also have the diameter, which is 0.02 meters, and the coefficient of the coefficient of viscosity coefficient of viscosity given as 2.7 times 10 to the minus 3. Okay, so we now go ahead and simply substitute these values into our formula for the Reynolds number. So Reynolds number equals, we have the speed, which is 0.55 multiplied by the density multiplied by the diameter divided by 2.7 times 10 to the minus 3. Okay, which should give you the Reynolds number of about 4,278. Okay, now because Reynolds number is actually greater than 2,000 in this case, we expect the flow of this blood to be turbulent. So the flow is actually not smooth as we predicted and as we know. Okay, so now we can conclude to say the Reynolds number is equal to 4,278, which is greater than 2,000. Therefore, the flow is turbulent. Okay, so we have answered the question. All right.